Yes, so we are starting now the recording. Thank you again for your presence. Thank you, João, for accepting the invitation. And I hope that you all enjoy. He divided the presentation in two parts. So after the first part, we're going to have some questions, and then he enters the second part. Okay? So thank you. Please, the stage is yours.
Thank you, Anderson. Thank you for the invitation. It's a pleasure to be here and talk about my PhD topic. I always like to talk about this, and I'm willing to share some information with you. So today we are talking about scientific integrity and how synthetic reality is impacting this science, right? So let's begin with motivation here. So anyone here already worked with some researchers, maybe working on a laboratory? And do you know anyone across the ethical line in science? You can raise your hand if you know someone. Well, don't be shy. Okay, maybe questionable, like a questionable practice. Yeah, so some more hands are raising here. Okay, so actually, there's a survey, the largest survey in the world is Dutch National Survey on Research Integrity, and claim that half of the researchers have at least a questionable practice in daily life. Like, and 1 in 12 researchers are practicing misconduct. So don't be shy about raising your hand. It's a common practice in science today. Unfortunately. Yeah, so let's go to some of this type of misconduct. Well, maybe you all know about the concept of the vaccine in the worldwide, right? And we have a paper from 1998 claiming that MMR vaccine cause autism. This is a famous article and cause millions of lives worldwide. Actually, the paper had some wrong claims on that, and people start using these wrong claims to propagate misinformation. Okay, we have some limited time, so I have the question later. Okay, sorry. So people start making documentaries, propagating this in social media, and you know what caused, like we have a pandemic, and you know what happened there. But this is not only the vaccines, and this world is not only about a false claim. People are also using image manipulation on this type of scientific articles. This is a landmark Nature article that has more than 2,000 citations. And this was retracted due to problems on the image. So the authors manipulated some images on this article, and this is like a landmark for Alzheimer's. And people were developed drugs, pharmacology studies were developed after this work, and you know the consequences, like millions of dollars people trust on science. Well, this is a very serious problem. This is the image that they use in one of the images they use in the paper, and you can see they just like make a cop move on the image, claiming that this is a Western blot figure, and this is the cop move. You can align the two cop move here to check easier what's happening. And the retraction notice just say that there's a sign of excessive manipulation, including splicing, duplication, and the use of an eraser tool. So people just go to the Photoshop tool and erase things, publicate that, and they have more than 2,000 citations. Okay, but is image manipulation allowed in science? Anyone know what if we can manipulate images? No?
Somehow. But considering the area of exercise, it allows to simulate the result.
Yeah, so let's go to the experts for that, okay? So a collaborator of ours, the ORI, Office of Research Integrity, claimed that it's allowed, but you have to document everything. every manipulation you do in a scientific image, you have to manipulate. And also, if you fabricate some image, in other words, make up data, results, reporting, this is not allowed. If you falsify, or in other words, like omitting the data or changing the context of the data, this is not allowed. And even plagiarism, this is the most famous type of misconduct in science, right? Plagiarism. But there's like a gray area on that, because when we are dividing misconduct from error, this is really difficult stuff and cannot be done like for an algorithm. People have to check whether there was an honest error or whether there was a really misconduct and intention to misconduct a figure. So if anyone here that have already raised their hand and saw that someone is doing some research questionable act, please report to the expert. Okay, don't blame the person, don't spread the word of that. Report to the integrity. Unicamp have integrity office for that. FAPESP and other institutions have this. Make this for the experts. Okay, so let's go to the types of image manipulation that are inappropriate in science. We have a reuse image. So people are reusing the same image like a plagiarism, but out of the context. So they're using different experiments, claiming that they represent different experiments. This type of inappropriate reuse. We have copy move. Here I just highlighted 2 cells, but all cells are copy moved within this figure. This is splicing. So people create a splicing image through different objects. Here in this green circle here is copied to here. This green square is copied to here, and create another image through all others, multiple other images. All these images here are real case scenarios, and they were corrected due to this problematic type of manipulation. Here we have like a clear Photoshop type of manipulation, right? That people go to the razor tool and just brush the figure until it clean up the figure. Here we have a case of inpainting, where we use the same background and inpainting a blot that claims to be a protein on that. And more recently, people are using AI to generate image and push. So here we have the DOI of the publication. You can go there and check out that all these publications were retracted due to this type of manipulation. Most cases are concentrated in the biomedical area. And as you can see in this graph here, image duplication is the main concern of the area. People duplicate image in large scales. Recently, if you go to this purple bar here, you see that there is a new type of fraud, that is paper mill fraud. So I go to explain what is paper mill in the next slides, but here we can have like a landscape of what's happening here. The misconduct is concentrated in biomedical, and there is a lot of duplication. I don't know if this is a concern because people is not educated regarding how to reuse image, or they are intentional doing that. Okay. Okay. So paper mills. This image here, the larger image, was reused in the second publication, the third, fourth, fifth, so on. The same image is being reused in large scale, and they are really like a mafia of the science. Yeah. So actually, this is a website. You can log in, and people you have this type of service. This is the screenshot of the site.
Juno's Mafia.
Okay, so the research integrity officer from the United Kingdom saying that the organized crime rings that are committing large-scale fraud. Science, the large journal, said that at least tens of millions of dollars flow to paper mills industry each year. This is really serious. It's impacting our society in the ways that we are not really understanding. So they make like a really great offer for the editors. They are starting to bribe editors as well, offering 10,000 per month. This is a real from a paper contacting an editor, paying $20,000 to accept some papers. Just leaking some information from an email, again, bribing paper mills, bribing editors for accepting papers. Okay, what's happening? Most of you are familiar with Q1, Q2, yeah? Okay, so this is a graph indicating how many journals are citing paper mill articles. So paper mill articles that you can see are ungrounded science, right? We don't know what's happening there. They are fraudulent science. But there are really K1 journals citing them. People are citing something that is not really a science and investing money on top of that. Currently, as I showed before, more than 1,000 papers was reported as belonging to paper mills. This is enlarging. So how we detect that? Okay, so this is one talk of my PhD. We use provenance analysis for that. The idea is to understand how they are reusing images throughout the articles, how they are manipulating them, and pinpoint each of the papers that are from paper mills. So we start with a suspect set of articles, we extract that figures, parse their figures, and try to build a provenance graph. So this image here is reused, and from this image, and so on. We know that this image was published on this paper. We can track the paper and also build a provenance graph. How we do that? So we start with the document collection, extract the image, filter the image on the most important and concerning panels of the image, and we create a feature-based storage. So we are describing each figure using a CNN. You can use transformers, but create a feature vector describing each image that we allow us to retrieve the image later using similarity, for instance. So this is the big picture of each of so we have the input, already a parsed panel, and we start doing a retrieval on top of that image. Through this image, we go to the storage that we created, right? And we have a top K rank retrieved from that database. Some images are similar to the query, some are not. But for the analyst on integrity offices, the most important thing is deliver some ads that they are matching. So we go to the next step. We use key point-based features to match each image from the rank with the image from the query, right? And we can use homography transformations based on the key points that we extract from the query and the retrieval image, and we can align the content of each image. Using the key points, we create a context view that we will know how much of the area of each image is sharing on the query and the one image that was in the retrieved rank. Based on that, we have a shared area score. So this will help us to build that provenance graph that I showed earlier. Okay, some images from the rank match content with the query, some not. This is important because we can expand our rank based on the image that share content with that. We can go deeper on that, and we use the image that share content to explore more images that might be similar to the query. We couldn't retrieve it during the similarity search on the database. After that, we use the scores. So you can imagine that this is a adjacency matrix, right? For each image in the database, we have like a table saying for each image how much of its area is shared with other image in the database. From that, we have a adjacency matrix, and we can calculate the connected components from that matrix. And finally, from this connected components, we use maximum spanning tree to provide the provenance graph. Okay, so a step further than on that is using this image-based provenance graph and get the information of the documents, the scientific articles. So we know each one of the articles that the image was published. We go back to the document, and then we can go and generate this provenance graph and pinpoint which articles are from paper mills, which are not. Let's go to a real case. So this is a real case scenario where Elizabeth B. reported more than 100 papers coming from paper mills. You can go to her blog here. This is the source. All this slide deck can be accessed through the QR code here in the top. Okay, if you want, just scan it and go to that. So what is this type of paper mill? They are reusing image, as I showed earlier, manipulated image throughout a large set of documents. So manually, she annotated each image from this paper mill. We are trying to automate that with this algorithm. So her annotation have 121 documents, about 500 figures, and 2,500 panels. So to mimic a real-world case, we also include some distractors for our method. So the distractor role is to mimic a researcher or an office that receive a lot of documents, more than 4,000 documents, and want to understand if some of these documents are paper mill based or not. So we include more 4,000 documents, pristine documents that are not reported as paper mill. On this set, from these documents, we extract more than 5,000 figures, and we have more than about 50,000 panels. This is the result. Even with the distractor, our method could track each one of the reported cases by Elizabeth B. So here we have a graph with nodes that are documents and edge that indicate the relationship of each document, saying that if there is a sharing content between any node, so they are reusing content. This is really important for analysts because it includes a visual representation on what's going on there. Just a zoom in. So, for instance, this document here, represented by its DOI, is sharing content with a lot of other documents. Yeah, so this might be the source of the paper mill and the
power node.
Yeah. And yeah, so these are real case, and the algorithm just worked as we wanted. And for the image side, we also have the provenance graph. This is a real world case showing that we can also explain the region of the image that match among the nodes So the analyst would also have more information about what's going on in this web. But we have also some false alarms. From that distractor set that we included in our experiment, well, some images were strange, right? So we also found some similarity among these pristine images. And this raised 21 false alarms out of more than 5,000, more than 4,000, sorry. And as you can see, the linked image here from paper 1 is really similar to the paper 2, but they were not reported by Elizabeth. You cannot say that this is a paper mill or something else, but it's at least suspect, right? But our method has some limitations. There is these Western blocks here. They are used vastly sometimes, and they are really tough to perform some forensic analysis on them. So more than 400,000 research work use Western blots. They are used for detecting proteins and measuring expression levels of these proteins on laboratory. It's the cheaper way of doing that. So that's why they are using that. But they have a lot of problems on that. They are blurred. They are, at first hand, they are blots, right? So you cannot distinguish this kind of thing. But they are also blurred, so some algorithm that needs high entropy, they will not work on that. They have compression lab artifacts that also dificultate our methods on them. They are low resolution and pixelated image. And even like this is a recapture figure. So the person go to a screen like a monitor, get an iPhone, take a shot of the screen and using scientific articles. This is the level what I'm talking about. So as our method is based on key point based, they were not effective for this type of plots. And this is a limitation of our method. Well, there is some research opportunities other than just focus on Western blots. Anyone here knows Cielo repository? Yeah? Okay, so we start some analysis on them, on the articles from them. Just checking if Latin America is also doing some paper mills, right? Okay, we get more than 150,000 biometrical articles and use PubMed BERT, a large language model, to represent each abstract, and then we project this with Disney. This is a 2D visualization of the embeddings. The nice thing is that, well, we can parse this at least for language, right? We have the Spanish side here, the Portuguese. Most of the articles are in English. Okay. But also, we have some reported paper mills there. Some articles that are published on the Cielo that are also from paper mills. One thing that caught our attention is that they are also grouped in an island. So maybe the neighborhood can get more information about what's happening. We enlarge the neighborhood, getting the abstracts. They have more similarity than 0.94. And check out the resultant graph. So I know this is a complex visualization. I could not improve that. Sorry about that. But the red nodes here are all reported articles from paper mills. The red edges are articles that have abstracts similar, more than 94%. And we are looking at lots of edges in red here. So these are really suspicious. So the next question is how we can combine the image algorithm that I just showed to you and the text information that I just showed you. This is a research opportunity. We already have some results, but we are not showing today. Okay.
And Horus wants to identify that. So this is a very nice opportunity for people looking for masters or research in this.
Show up. Okay, now question, right? You had a question that time.
So people, if you have questions, please, if it's possible, if you can come closer to ask the question, it's better because we are recording.
Can you use the mic? Is it working? It's working?
Yeah.
Please. Yeah, it's good.
So when you identify first the abstracts, okay, you can use first identifying by the similarity and text, and then you can use the second step running over the images.
Yeah.
But how can you better assemble that? Maybe you give more importance to the images. And the other question was, I saw an article about too much trust on AI and how is it affecting the subject of the study?
Okay, the AI part we can discuss later, but the first, regarding the first question, okay, we can combine this kind of thing. But actually, for the Cielo repository, the images are really low resolution. They are not available in a form that we can represent or extract the key points-based feature that I showed. So text information is really important in this matter because the images are really low quality. And for when we have some high quality image, maybe we can go and do the other graph, trying to check if we have some information from the documents and if it's matching with the abstract based approach. But this is still an open area. We didn't explore it too much. Any other questions?
No?
So you say that a half of all the works published must have some misconduct?
No.
Is that right?
Sorry, I didn't say that. I said that half of the people from the survey that we looked, it's a Dutch survey from Holland, people said they identified questionable research
In their careers.
Yeah,
Wow.
not
About the people.
yeah, about the people, not about the work. Okay.
How you divide when a practical in an article is a misconduct or is just a manipulation, punctuality that is not prohibitive?
So outside the types of image manipulation that I showed, that is clearly evident that there is like copy mode, there's a reuse without proper citing or AI generated. So the best way is going to an integrity office and expect a resolution from them. It's really hard because if you are blaming honest people that just make an honest mistake, that will go like a witch search, right? Witch hunt. We are not looking to that.
But his question was, what kind of operations are allowed? It's
allowed?
Like brightness change, contrast change, compression. These are allowed, but they are manipulation.
Okay, so you look to detect all this type of manipulations.
Some of them, in my research, I detect some of them.
I mean, because some manipulations seem to be okay to you know, if you want to put a graph about results, so you just want to hidden some columns of the graph, and this manipulation is made up after the graph was generated in the Python, you know. So it's not. I mean,
maybe you know someone that did that, right?
It's okay. It must be okay, but I understand in your presentation that it will be prohibitive conduct.
No, this is not a misconduct, right? But if you do that, document in the paper, document in the document or research document that you are doing, so it's clear what happened there. Because when I extract the figures, actually I go to the PDF embedding figure, and I can know that you did that. I can see that you manipulated the image, and looking only to the image without context, this is a manipulation. I don't know your intention about that. Okay.
So you look to detect any manipulation. You're not judging if
Yeah.
it's a manipulation.
Yeah.
Declarative or not.
That's why we always want the human in the loop.
Any other questions?
Thank you. Okay. Thank you, João, for the presentation. The question of
Okay. It's just the part one.
Thank you very much.
Thank you for the first
presentation. For the first part of your presentation, my question regarding this situation about honest error and also intentional error. Have you explored this to identify? I know that we need a human in the loop to properly identify if it's a honest error or just a misconduct, but have you explored any kind of pattern when I have an honest error or when I have intention in the forgery? There is any kind of pattern where we can classify or somehow help the experts to identify that no, this is an honest error, or no, this is a real misconduct of the research.
Using algorithm to do that is really tough. We know that there is some misconduct, especially on this type of fraud, using when people systematic use frauds like reusing the same image throughout 100 papers. So this is likely a fraud, right? But for like Photoshop operations, it's really hard to say what's going on there. My work is just detecting that there was some manipulation there. I leave to the analysts and the experts to say what's really is the intention of the person.
Okay, thank you.
Hi, João. Thanks for the half presentation. I'd like to understand better about text in images because I don't know how your method will understand these texts. I understand that this may be a different operation from what you just presented, but is there a way in your method, or this is not the focus of what you're seeing, to detect if the text has been added or manipulated in the image we're seeing? Because I believe that in some PDFs that you may analyze, you're going to see some images like that will be needed OCR to be understood or not. Or this is not the case, I don't see this stuff.
Yeah, this is a really good question. I didn't explore this in the presentation, but text is really an issue for us because, well, every text on science is similar to each other, right? When we include the text on the image, it's similar through all the papers. We can try splicing operation, so people are including something there. The artifacts from the text are different from the artifacts of the image. This is okay. If we go through this path, we will go like crazy because every image has some text overlaying the image, or text, or arrows, or scale bars. Well, a lot of types of things. But we try to use OCR and ignore the text, but also we have a lot of false alarms when doing that, and we will start ignoring some important content of the image. Our approach of using the convex hue and the area of the image, it allows us to also ignore the text, because the text is basically a small portion of the image, right? So if we are analyzing the area that one image is sharing with another, and is a really significant area, so we can ignore the text, and if it's included there, it's okay. But this is really a tough thing. It's a good question about the text. Okay.
Let's continue.
Okay. So we can use AI and make life difficult, right? And we already have starting hearing about synthetic text on articles, people using ChatGPT to create text on articles, right? Well, this sooner or later will be used by paper news. And they would scale their production. If now we see 100 papers, they would be like thousands or millions of papers published by them. And we know that they can write editors, right? So it's easy. You just ask ChatGPT to create a fake paper and write the editor, then you have your publication. That is how we're going to see in the future. And actually, there are a lot of tools, popular tools, that can do that job for us. We have DALL-E 3 to create scientific image. We have Midjourney, Hugging Face, ChatGPT, a lot of other type of popular tools that you might know best than me. Okay, so this is a sample of people creating scientific articles using ChatGPT, and they included the prompts from the ChatGPT.
Certainly.
Certain. Here is a possible introduction for your topic. And the article was retracted.
Yeah, but it was retracted after the reader
Yeah.
spotted out.
Someone reviewed that,
Editor
accepted. This was published.
It was published. You can see there, March 2024.
The editor was using ChatGPT to analyze the articles.
Yeah, it passed peer review with this. Okay, this is a complex topic because we have some tools to detect synthetic content, synthetic text. But some studies are showing that this type of tools also raise some fairness issues. Because, like me, someone that is not native in English, when I wrote, the tool will say that my type of writing is ChatGPT-like. And okay, so how can I write then? This is like a really complex issue. So to detect what is going through the ChatGPT, what is non-native writing, and we don't have a solution for that yet. Maybe Horus can provide one, right? That's it. And ChatGPT can also create data. What I mean by data, like when you go to the lab, generate some numbers on an experiment, you can ask ChatGPT to do that. No one will know if you do the research or you ask ChatGPT. And this is coming to a reality today, even to the images. So this is a study, again, the blots, this type of image. I studied from 2020, asking experts from the biomedicine area if they can distinguish what is real and what was generated by AI. The result is that 50% of the case, they miss it. So if you tip a coin, it's like a random guess. Like you tip a coin, 50% of people would say that image was AI generated. And we also work with that. This is also some other plots that we create. And people cannot distinguish this from real world images. And it was really published on Science, AI image generated. Okay, I tried also using the popular tool. Let's do the dirty job, right? So I asked Midjourney, DALL-E 3, Firefly to generate these plots. I used the same prompt on these tools, and only DALL-E 3 could provide this one. But it's really like good one. If I publish this, I believe no one would expect coming from DALL-E 3. This is the popular tools, but as a computer science, we can also fine-tune existing models and create really realistic image here. Using, for instance, stable diffusion, right? So I have a question for you. Can you identify what is pristine here? We have only one pair that is a pristine image here. Can you point if it's A, B, C, or D? Which one?
D or A, but
D or A? No one? Well, I should bring up chocolate. Okay, so the pristine one is D. The other was generated by pix-to-pix, stable diffusion, DALI tree. And these I just collect from pristine repositories. So now how to detect this kind of thing, right? It's just a real threat to the science, how to detect them. Let's go to that. So this is a pristine image here. And if you look close to the image, you don't have like some artifacts that is included in the AI generated one. If you look close, you check that AI image have this kind of checkerboard artifacts. And this is also visible on the Fourier spectrum. When we analyze AI image, we can check that there are some peaks on the Fourier spectrum that are linked to the AI model. So how this is generated in the image? All models, all generators that we have so far, at least that I know, use the convolutional operations. So they start with flat embedding and start deconvoluting the image until they embed it until it gets the form of the image. So imagine that we have like a vector that is changing its form and starting to get an image. And you have to make some upsampling for that. During the upsampling, the convolution operation might have some overlap on each pixel of the future image. And this overlap creates this checkerboard artifact that is detectable. Not only the checkerboard artifact is detectable, but also this deconvolutional layer creates a linear combination of the generated pixels. So we can exploit this to detect the images. And this is nice because each model has its own deconvolutional process, and each model left some different artifacts in the image. So here we are looking to different types of Fourier spectrum with different types of peaks on the Fourier that can allow us to attribute this spectrum to the model that generated it. So here is using a Western bot that we generated. Here are some artifacts from cycle gun on the Fourier spectrum, DDPM, pix-to-pix, style gun, and pristine. And here is a Tizen visualization of these artifacts. So I just extract the peaks and represent it in a 2D form using Tizen. Well, it's really separated in the space, the 3D space. Sorry. So how we get the image? We extract a residual noise from the image. Then we analyze this Fourier spectrum and also analyze the texture of the image. As you saw, there was this checkerboard texture or some linear combination of the texture that can allow us to detect this type of image. And then using this image based on the Fourier, on the texture-based features, we can plot or we can represent these features and attribute to the source model. To make it more robust, we split the image in patches. So we will not like focus on the semantic image, but the residual noise and the artifacts that are in the image. And these artifacts is through the entire image. We extract the Fourier of each patch of the image and then create the average spectrum of the image. For the texture-based analysis, we are using the GLCM matrix, the grayscale concurrence matrix. This is a well-known type of texture analysis. So this is a grayscale concurrence matrix of this image. We extract contrast, homogeneity, dissimilarity, energy, and correlation from this matrix. And from that, we have some features to distinguish what is real and what is AI generated. So these are some spectra from the GLCM of this image here. As you can see, each model here have a different spectra. So we can attribute based on that, based on this spectra. We can make it even more robust and use the Fourier throughout the grayscale concurrence matrix and make it even more distinguishable between the images, the type of generators. So this is like a comparison of Fourier-based, a patched-based Fourier, a grayscale spectra, and a Fourier grayscale spectra. So these two spectra here is proposed by us and have more robust features than the others, and is even more easy to highlight which model generate each type of artifacts on this type of spectrum. So to make some experiments on that, we use OpenSet classifiers. So we only train the image on the classifier on real image, and then test it on the AI image and real one, aiming to check if we can detect AI-generated images only using pristine images. So the results are here. The patch-based Fourier features and the texture-based Fourier have like a high score for that. Here I'm using the classifier isolation forest and also probabilistic PCA. Both works great for these type of features and have a really nice results. This is in a cross-validation protocol. And also, if we are aiming to attribute the source model, we can use this type of training operation that we train a classifier for each type of generator, and later on the test phase, we get the classifier that has the highest likelihood for each image. And also the proposed features that we have has also a high score here. We check it also with transformer-based features. It's robust when using PPCA. It's really, it has a high score when using PPCA, but it doesn't work with isolation forest. Okay, but we have some limitations regarding this. This operation, these artifacts can vanish when we apply blur operation like low pass filtering. As you can see here, the artifacts that was generated by AI just vanish when we blur the image, and we can't distinguish what's the reference and what's the blurred image. Like, so I did some experiments on that and tried to blur the image for each type of generator and use a JPEG compression and low resolution image. These are typically figures from the science, and all the artifacts are diminished when we visualize this after these operations. For the JPEG compression, we still have some type of artifact here, but some others just vanish. It's really tough when we do some post-processing on this type of image. And also for the lower, other type of artifacts appears, and we start losing the previous artifacts. And this is an open question. We don't have a straightforward answer for that. How to have AI-based fingerprints that are robust to post-processing. One thing is that scientific image should not be low quality, right? We should publish high quality figures, so our methods also would perform well on that. Not only for the AI generated, but for all other types of forensic methods. These are a discussion that people from publishers and journals have to have in mind. We cannot publish low quality image. Because as we saw, people are taking photos with iPhone from a screen and publishing on sites.
Many journals are requiring now the minimum quality of DPIs for each image, but it's not the standard for all publishers.
No. We should lack a guideline that is acceptable for all the journals. So, yeah. Okay, so any questions regarding this?
So, you mean that post-processing is blurring the image?
It's
one of them.
Yeah, one type of post-processing. This is as I showed in some slide ago, this is a really, sorry, here. So they are common on science. People blur image, have low quality, low resolution image on science. We capture artifacts compression. So I test the model regarding these artifacts.
One important point to make here is that, historically speaking, faked images, people will try to make them smaller and blurrier because it makes your life more difficult to find the forgeries. So when you get something in WhatsApp, and if it's low, you can, I constantly think that, okay, something wrong is here because it's not common to have something that's so low resolution, right? Especially now with like a megapixel cameras. And that's the same in science. So authors who want to hide something, normally they will try to add some artifacts in terms of blurriness, compression, pixelation. So why blurriness? When you apply blurring filter in an image, it's also a kernel that you filter in a region like 3x3, 5x5. So if you think of the process of going with this kernel 5x5 in each position of the image, you're adding another artifact that was not present there. But we already know in forensics that it's possible to detect added blurring. So there is a process of detecting added blurriness, but then it's like a cat and mouse, right? So people will now project with a very good projector the image on a wall, and then they take a picture of the wall. So now it's a photograph, but it's a photograph of a wall. But you can also detect this as recapture. So it's like every action that the person does, you need an algorithm to detect that. It doesn't scale, right? So that's why he's posing this question, and it's a question of Horus. What can we do to find more robust features in terms of detection for AI-generated content?
So when you blur the image, you cannot recognize that clear pattern.
Yeah.
They are these explainable artifacts that he told, they decrease as you do blurriness. But also, when you do blurriness, you add another artifact, the artifact of blurring. Because one thing is, a natural blur will not have this 5x5 pattern. But an added blur, if the person uses the kernel 5x5, there will be a pattern of 5x5, or 3x3, or 9x9, it depends. But there is natural blur. If you take a picture of something in motion, in nature, or like a car going on the street, there is natural blur there. It's not something that some person went there and filtered. But if the car is stopped, parked, and you take a picture, then you add blur in Photoshop, then you can see that there is added blur. Okay? More questions? So you can take this opportunity because this latest result that João showed is still not presented. He's going to present this in December in Rome. And you saw it firsthand here, which is a very good result, by the way. It's the latest thing of your thesis, right? The last of the last.
Yeah.
Now it's just the defense. And after the defense, you have this presentation in Rome. So, guys.
Okay, just something. If you want to test yourself and also help us, we have a survey that is going on to detect what is fake or not. The survey is on this QR code here. You can scan and go to that and help us to understand better what's going on.
This is our next work.
Yeah, and if you want to have these slides, you can scan this QR code, okay?
By the way, very nice keyword. I didn't know. Now I'm gonna ask everyone from Recod to create a QR code like that.
Okay, thank you.
Thanks a lot. So everyone in person here and online, thank you for joining us today. I will put this presentation online in our YouTube channel from the Institute of Computing. And if you know anyone who would be interested, you can send the link later on. Thank you. Bye-bye.